bond valuation question with basic algebra, or a very hard perpetuity type of question? Which one would you want to do? Really quick, what do you have in mind? I'll let you guys decide, or else I have an idea of what I would like you guys to do. Of those 4 questions, which one would you rather do? Bond, portfolio. Okay, question 10. Cool. Okay. So this one's awesome. It's really fun. It's not hard, but like it may be a curveball on an exam. So in 10 minutes, we're going to go through it as much as we can. So this question is time value of money. It's a flowchart question-ish. They tell you what it is, and you need to solve for the present value. It's definitely a question at which you kind of need to just put stuff in perspective. Some of you may have done it with me, but it's still very important to understand what to do. So we have the Yotsuba group. I took a lot of Japanese inspiration with this with this exam, but it pays a $140 perpetuity at the end of every 5 years, okay? Starting at the end of this year. So already, we know that payment is equal to 140. That's a guaranteed. But we also know that these payments are happening every 5 years. So they're not happening, every year, but they're happening every 5 years. So that's pretty complex. And in other words, where they're being nice to you, they're telling you, hey, the first payment's at year 1, the second payment's at year 6, and so forth. They're also telling you that, the discount rate is 8.3378 compounded 4 times per year. So if it's compounded 4 times per year, it's compounded quarterly. Yes, amazing chain. So now we're asking you, hey, what is the present value of this perpetuity? So honestly, on an exam, I don't even think you need a timeline, but it will help you a little bit. And that's why I'm going to kind of be forward looking and kind of work in reverse. So let's say that this is T0. So we're going to have T0 here. You'll see why later. And we're going to put we're going to continue this all the way here with T equals 6. Okay. So we can drop our payments really quickly. We know that we're going to have $140. We're going to have nothing here all the way to essentially year 6 and so forth. We for sure know we're dealing with a perpetuity because the question tells you so. You're dealing with a perpetuity. So what you want to do, I would say, on an exam, because you know it's obvious that we're dealing with a perpetuity, just simply kind of write it down. Have it next to you. It's always good to understand what our formula is. So we know that P0 is equal to payment 1 over K. Okay, so we know that. The thing is though, and you should notice by now, when we have perpetuities that are spanning multiple years, as you can see, this one spans essentially 5 years, right? When you have perpetuities that span so much time, it's very important to group them together, okay? Whoops. It's very important to group them together. It's something that you must have seen at this point. And it's really a trick that we're going to use in several questions that we're going to be covering within these these mock exams and online mock exams, okay? So now what you want to understand is that when you have a perpetuity and there are missing payments or unexistent payments for a few years, then that payment of $140 happens again, then there's a few years where there's nothing. It's very important to group these 5 years, these years occurring as one large payment. So now what we're doing here is we're saying we have a payment, right, that spans 5 years in perpetuity. Essentially what we're saying is that we're saying we have a pattern of payments occurring every 5 years, such that we could draw up our formula as being something like this. Payment 1 to 5, because we're dealing with T1 to T5, over K will give us our present value, okay? But the thing is, when we do have payments that span multiple years, we have something to do. And that something to do is to adjust our rates, is to adjust our annual rate to something that actually covers the entire period of our little grouping that we did, okay? Think about it. Because if you were to invest that 140 at T1, you would have the opportunity to compound interest not once, but several times. You'd have the opportunity to compound interest I'm sorry, I drew it too many times there, but you'd have the opportunity to compound interest essentially I can't do math today, but 1, 2, 3, and 4. You'd have the opportunity to do so for 4 years, technically, okay? But realistically, it would be spanning 5 years, okay? You'd have the opportunity to compound interest for quite some time, and because our time is taking 5 years, we need to adjust our rate to actually span those 5 years for it to be an effective rate for 5 years. It's a little bit like what we had in the previous question. This example that's in green right here is definitely going to apply when we're solving for missing cash flows. That's why I kind of went in that end to kind of give you more exposure to that. But the thing is, in this question, we aren't given an effective annual rate. We were given a quoted rate that is compounded quarterly. So what we need to do is we need to bring our quoted rate to an effective annual rate, and then we could change it to an effective periodic rate. Okay? So once again, when they give you a random number like this, followed by compounded blah, 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 or even to make it easier for you, if they don't say EAR in the question, just know it's a quoted rate. If they don't say effective periodic rate or effective annual rate or effective quarterly rate, if they don't say anything effective, but they just give you a percentage followed by compounded, you must know and you must think that that is a quoted rate. So in this case, we're going to solve for EAR. And I'm going to ask you all to tell me what that is. So you're going to have this plus this percent divided by 4, power of 4 minus 1. Can somebody tell me what our effective annual rate is? Somebody tell me, what is our effective annual rate in this case? If we know it's 8.3378 compounded quarterly, we would plug it into our formula. 1 plus 8.3378% divided by 4, solid. In this case, I would definitely recommend keeping 4 decimal places, just because it's a longer question. So this is our effective annual rate. Now we need to solve for our effective periodic rate. And if you look into the top of this document, you definitely do have the formula to bring an effective annual rate to an effective periodic rate. And the best framework to apply here is to understand, well, hey, we're just looking at it as if we compounded 5 times. So what you would do is simple. You would do 1 plus EAR over essentially 1 over 1. Well, the exponent would be something like this, minus 1, such that you'd have this as your exponent, right? 1 over 1 over 1 over 1 divided by 5 gives you essentially 5 as your exponent. And with that, you'd be able to solve for your effective periodic rate. Can somebody tell me what our effective periodic rate is? You guys are absolutely awesome. Exactement. Okay, so before we proceed, I'll give you a quick summary. What we did is we know that we have these payments occurring every 5 years. So we decided to group them, these payments, as one general perpetuity, right? But because we grouped a single payment into a larger, like big payment that spans multiple years, we need to adjust our K. So in order to do so, we essentially use the formula as you see below, right? So it's essentially just compounding interest for X amount of years. Now, let me ask you this. Are you guys okay so far? Like, is this super easy so far? Yes or no? Quick yes, quick no, just to make sure. Yeah, okay, cool. Okay, so now the next step is pretty straightforward. We need to just plug our stuff in into our formula. And I guess I'll go with a different color. This. Okay. So you would just solve for the present value, right? And essentially you would do 140 over 51.0751%. Somebody tell me, what does that give us? What do we get from that? What is our answer? Perfect. Thank you, Shane. Okay, so now there's just a small nuance to kind of highlight here. We know that when we use a perpetuity, right? If we had simply call it payment 1, we know that our present value is always a period before, right? Thus the formula Pn is equal to payment n plus 1 over k, right? We understand that. However, that's for essentially payments that span only 1 year. However, what happens when we have payments that span 5 years? Well, in those cases, what we need to do is we actually need to go back the total amount of years that were essentially grouped. Okay, trying to draw this, but essentially what we're saying is that if we spanned 5 years, this means that we need to go 5 years in the past. Okay, if we are spanning 5 years, if we're spanning X amount of years, this means that we need to go X amount of years backwards to get our present value. All right, such that in this case, we're spanning 5 years. So we're going 5 years backwards because that's what a perpetuity formula does. So we're going all the way here. So we're going -1, -2, -3, all the way to -4. So it turns out that we got the present value at -4. So what we need to do, Shane, great question, great follow-up. Well, we know that -4 is definitely not today. So what we need to do is we actually need to compound interest all the way to T0, all the way to today. So what we need to do is actually, we need to compound interest for an additional 4 periods. So in other words, that value that you got, that PV -4, you need to multiply that by K to the power of 4 to get your PV 0. A few things before we proceed. Remember that the perpetuity formula always brings you back the amount of years that are added right here. So if you span 1 year, you're only going back 1 year. If you span 5 years, well, this is actually n minus 5, right? Essentially, or yeah, pretty much n minus 5. So in this case, we need to essentially compound interest all the way back to PV0 because we want to get to today. This is what matters to us. Okay. Now, two questions. The first one being, what would be our K? What is our K? What are we going to add here? Somebody tell me in the chat. What is our K? We're compounding for 4 years, therefore we're taking an annual rate. What is our K? It's somewhere on the screen. What is our K to get back to t equals 0? If we're compounding for 4 individual years. So 1 year, 2 years, 3 years, 4 years, which is why our n is 4. Bravo, Shane, super solid. Yes, our K would be 8.602%. All right, and then what would be our present value 0 then? If this is 274.10, right, and this is at -4, we need to compound interest for 4 years all the way to t equals 0. So it must be bigger than 274 will be. Exactly, it's 381.30. Now, before we tie a bow on all this, I want to break it down again. A perpetuity formula is really interesting because it brings you back one period, right? If your payments at T1, for example, is going to bring you back one period. If your payment spans X amount of years, more than 1 year, it's going to bring you back the number of year it spans. Okay, so let's do an example. All right, we have t equals 1. All right, yeah, t equals 0. Just to really double down on this fact, if we have a payment that spans 3 years, okay? So it spans 3 years. So at T4, there's going to be another $200 right here. So T equals 4. If this spans 3 years, and we know that this is payment 1, the present value that we get is going to be at what? If we know this spans 3 years, so we need to go back 1, 2, 3. Where will we be? -1 minus, what will be our present value if we're making a payment span 3 years, right? Such that our present value, right, would be at what year? It'd be at -2, exactly, all right? And if our payment was to span only 2 years, our present value would be at what period? It would be at -1, okay? So then we would just have to essentially compound interest for 1 period. Now I'm gonna give you guys another example. And actually, I'll go here, it'll be easier. Actually, no, yeah, I'll go here. Shoot, I don't have any, give you guys another example quick. Let's say that this is 0, 1, 2, 3, 4, 5, 6. Let's say that this is 100, 0, 0. Okay. So let's say that our payment spans 2 years, okay? And we're using the perpetuity formula. Our present value will be where? If we know that this spans 2 years, where will be our present value? It's going to bring us back where? Exactly. We're going to be here. So because we're only here, we would then need to discount another period to get to P0. So we would have to do this, power of 1. Okay? So that's just context on this idea of how to play around with this perpetuity nonsense, how we're moving all over the place, okay? It's very important for you to understand. So once we did that, it gave us a value at PV minus 4. PV minus 4 is not today. PV minus 4, I'll write it here. PV minus 4 is not equal to PV 0. But we're not going backwards anymore. We're not going backwards anymore. Now we're going forward. We're trying to go towards the future, technically, right? Like 0 is after minus 4. So because we're going all the way here, we need to compound interest. Okay, we need to compound interest to get to PV0. And that's why we took 274.11 times 1 plus k to the power of 4 to get 381.30. So is that fair? Do we understand what we did here? Everybody, is it like a yes? Are there any questions before we go for today? Okay, don't you worry.